Hello and welcome everyone to another Mountz webinar. Today we are going to talk about data collection, and this data collection is directly linked to several aspects that most of you already heard about: Industry 4.0, Internet of Things, and MES systems. Before we move on to that, as we invited some French-speaking guests, I want to just give them a few words as we continue our webinar in English. Si vous regardez cette présentation, elle sera faite en anglais, donc vous pouvez toujours me contacter par mail ou par téléphone pour avoir une présentation faite sur mesure en fonction de vos besoins. So I'm Adrian Auger, Technical Sales Manager with the Mountz International team. I have more than 10 years experience in the assembly industry, and I've seen many challenges faced by our customers around the world. This gave me a very good experience and insight and knowledge that I'm willing to share with you today. Some of you as attendees are end users, some of you are distributors. So here, during this webinar, we will take the approach that we speak to end users. So if you are a distributor, please understand this webinar and look at it from the point of view of your own customers. So Mountz is a company that was founded in 1965 and is a family-owned company. We have been leading the industry of the assembly tools since then, and we've now developed with 3 different locations: our headquarters in California, main facility in Alabama, and our newly opened international sales and service center just outside London in the UK. Mountz has always been focused 100% on torque. This makes us expert and have a lot of knowledge about every aspect of torque and assembly tools. As a leading company in the industry, we were the first to develop an electronic torque analyzer for a very famous defense company in the early 70s. Of course, since then we kept on innovating and have product launch on a very regular basis. Our customers operate in many different fields, being medical, defense, automotive, aerospace, electronics, just a part of those. Now let's move on talking about data collection. And a very important aspect about data collection is that it's linked to the graph that you are seeing now displayed on your screen. So what this represents is a lean theory. So every production worldwide, whatever they produce, have the aim to have a perfect production line, which is here represented with the dotted line, sorry. With a lean production theory, we have 3 aims, and the first one is the Mura. Mura is basically representing everything out of the lean production that prevents from reaching this goal. Zooming in, we can see that there are 2 parts of the curve. The upper part is the second M, Muri, and the third M is Muda, the lower part. Muri represents everything that puts a burden on the production, everything that slows down the process, and the Muda represents every waste directly linked to the Mori. Waste can be in terms of workforce, with people having to rework or spend more time on application. It's going to be time, financial loss as well, and parts included. So to tend to a lean production facility, it's of course important to collect data. The first point of collecting data is to have the tools that can send out this information, and also the tools to be able to collect this information, so take this information in. Once this information is collected, it gives you a very good visibility on all your production line, but also on each workstation. So it gives a complete insight of what's happening on the production. Once you have this insight and visibility, you can then take the decision based on actual data. It's not based on theory or thoughts, it's based on real fact given directly from the production line. These decisions will help tend toward a leaner production, reduce the Mori and the Muda, and help you improve the processes, reduce your waste and cost, and of course, reducing your cost, waste, improving profitability, productivity, and quality will result in being beneficial for your company. So when we apply these principles to fastening and assembly lines, there are some aspects that are here very important. There are now solutions with assembly tools that will give you all the torque and fastening data that you need. This data can be linked to different things. And again, this fastening data will help you optimize and improve your processes, whether it's torque related or error related during the assembly process. Talking about error, data collection is of course linked to quality control. This is actually at the heart of quality control. The data collected will give the errors that's happening on the line, every little aspect that the quality can improve to help correct the problem before the work progresses. This can be linked, as an example, to real-time data being collected, allowing the quality control team to detect in real time when an error is happening and act on it before the part moves on to the production line 3, 4, 5 workstations later, where the rework would have to be heavier and take longer. Worst case scenario with this kind of situation is that the part leaves the production line, leaves the production facility, reaches the end user, and then we have a product defect where the product needs to be returned to the factory to be reworked. So this is where data collection is going to be a key aspect of quality control. We have now more and more tools that give information on assembly lines, and these production records will help many companies face different challenges. The first challenge will be audits, whether they are internal, external for customers or from ISO bodies. Collecting the data and having the information of what's happening at all time on your production line, as well as keeping a historic of it, will help face the audits successfully and give all the data already ready in hand. Oops. This fastening data can also be linked to specific products, IDs, or specific product lots. So this will give full traceability of what happened on a specific product, so that even if this product or lot leaves the production facility, you will be able to check back what happened on this product and see if any error was detected during the assembly or if everything went smooth and easy. Finally, fastening data will help you and your customers. We all have customers, whether you're a distributor or an end user, we all have customers. Our aim when producing tools is to supply them with tools that meet their requirements, and collecting the data will help you show your customers that those requirements are met. And on your side, if your customers' requirements are not met, take the action to optimize your production line. There is a very important aspect of optimization that I want to highlight now. Optimizing is not always making things faster. As we've started this webinar, we talked about a leaner production, and this is where we can really optimize the production line. Optimizing is tending toward a leaner, smoother, more even, and more efficient production line, where the aim, again, is this dotted line that we saw at the very beginning, where everything happens very smoothly on the assembly. As we talked about collecting fastening data, there are two main ways of doing that. One of the most popular ways is to have tools to control your production tools. Here, in this example, we have torque measurement instruments in the form of a PTT torque analyzer and a rotary torque sensor. A big advantage of these rotary torque sensors is, as you can see, that they come between the tool and will be used directly on real production. As end users, it means that you can keep on producing, keep on assembling, generate waste, and you take measures of torque of the tool at all time, check if your tools are in line with your requirements, with your customers' requirements, and make sure that if anything needs to be changed, you have the data to do that. Rotary torque sensors, as you can see on this image, can work with hand tools, they can work with electric tools, they can work with pneumatic, air, and pulse tools, and they can also work with DC control tools. DC control tools have been launched for quite a while now, and they are becoming more and more popular in many different fastening and assembly production environments. The tool that you see now on your screen is the latest ECTD coded Mountz tool, which is a transistorized DC control tool. We also have non-transistorized DC control tools, coded, as well as transistorized battery tools. If you want more information about the difference between transistorized and non-transistorized, we can answer those in a separate session. Coded tools, battery tools will, generally speaking, give out more or less the same information. As there are many suppliers of very different level of quality. I want here to focus on the Mountz tool to give you information of the type of data that you can expect to collect when using these tools. Again, as we've mentioned, the ECTD and the ECT tools are transistorized tools. This means that the rotary sensor that you've seen just a bit before is actually built in the driver and ensures a constant torque control of the delivery of the tool. The aim of the torque sensor is making sure that the tool stops when the target torque is reached. The ECTD tools will give real-time monitoring, whether from the screen, IOs, to make sure that you have all the information in real time, making sure that if anything happens wrong on the workstation, you have the ability to act on it immediately before the waste becomes even bigger. These tools come with different IOs for being a full part of workstations, so they can be integrated with PLCs to make one with the workstations and the assembly line. They give out all the data related to fastening that we will detail just later on, so that you can keep track of that in real time, but also keep a good record of them. When we talk about assembly tools, there is one data that is, generally speaking, the most important and valued information for the customers. This is the torque. When you use a tool, you want to make sure that the torque delivered, so the final torque, is as close as possible to your target torque for your application. These tools that you see now on the screen give both value, allowing you to make sure again that the final torque is as close as possible to the target torque. And if you see a bit of deviation, you have then the settings to allow you to really adjust the tool, ensuring a great and accurate, repeatable torque delivery. Another important aspect of DC control tools is angle measurement. Angle measurement can be used in different aspects. It can be used as an example for angle strategies where the driver and the fastener needs to be fastened at a specific angle, but it's mostly commonly used with torque targets where the angle will be, in that case, working as a proofing item, making sure that not only the torque was reached, but that the fastener was tightened properly between the minimum and maximum angle window. This will help prevent cross-threads events, as well as events where parts, washers are forgotten during the assembly. On top of the angles, another important data is date and time. Of course, you want to collect this data to be able to keep track of your data, allow you to go back in time, see what happened, when, and exactly on your production, making sure again that you can link this data to your products. Screw counting is important in some occasions as well, where when combined to the first torque angle windows, you make sure that every screw is actually present on the part before it moves on to the next station. So then you know that each screw was properly tightened and that all the screws are actually on the part before we move on to the next station and the part go its way. And then another data is the type of error. So the error type is going to be a real guide for you, in the sense that it's very important, of course, knowing when something goes wrong on your assembly, but you want to know what went wrong to be able to take the corrective actions. The ECTD tools will give you error codes, will give you signals on the front panel, allowing you to identify these errors and then make sure that you take the actions to avoid having them in the future. All this data can be linked to barcodes, whether for individual products or product lots. The barcodes can be used to call fastening strategies or fastening presets, but they can also be used only as identifier to collect the fastening data and link them to these barcode values. All this data will be available from Modbus and Open Protocol, which are communication protocol very commonly used in networkings for industries. The coded tools work with Open and Modbus protocol, while the battery tools work with Modbus protocol for now. For those of you who don't have a network, we thought about you. That's why we integrated an SD card that is recording at all time every event on the tool. These records are saved on a CSV file so that you can open them and exploit them through Excel. And each file is going to be saved depending on the day. So it means that you have a separate file for each day of your production, making it easy to browse through all this data and finding exactly what you are looking for. A feature of the tool is that it can be locked if the SD card is not inserted and properly working into the controller. This makes sure that no work is done without being tracked and all the information saved onto it, ensuring once more 100% traceability of the work done with these tools. So now that we've talked about the theory, let's see how it works in practice. If you have...
Okay, I found this on the web for
If you have any question during the practice, during the demo, feel free to write them down in the chat, and we will answer those at the end with a Q&A session. So what we have here on the screen are three different items. On the bottom right, we have a screw plate where we can simulate parts being assembled. On the top right, we have the controller with the touchscreen. And on the main window, we have the software that comes with the tool. The software is license-free. So once more, it's included with the tool, and it can be installed in several computers around the production without having any license to be purchased or renewed. This can represent quite an important saving when using this type of tools. Looking a bit more at the software, I'm going to connect here through the RS-232 port of the controller, but we could also connect through the Ethernet port, and all the information can be sent through those two ports. For PLC integration, the tool comes with 25-pin I/O with a very wide selection of type of input and output commands that can be selected. Going back to the software, we have here two main windows. The first one is related to settings and actually programming the tool. We have here our 15 different presets with 15 different target torque, 15 different angle windows and speed. But this was mentioned in another webinar. So if you have questions about that, I will be able and happy to answer those at the end or offline. Today we are focusing on the monitoring part. The monitoring part will mostly be divided in three categories. The first one is going to be real time, where we will be able to see what's happening on real time on the tool. And this is basically an exact copy of what is being saved on the SD card and what is being sent to the network through Modbus or Open Protocol. So if I start this real-time monitoring and make a fastening, we have here a fastening number 1 with the time of the fastening time, the preset used from 1 to 15, our target torque, our converted torque, so the torque that was actually applied on the fastener, the RPM speed, the different angles, and here we have the error column and counting as well. As you may see on the screen, on the controller, we have on the bottom right the screw counting. So we have now 2 screws left out of 3. And if I keep on doing that, it will be reflected on the data that you will see in the software. Now that we've done our 3 screws, we look back and we have again 3 screws left to fasten. So this is the scenario where everything goes right. And on the right hand side, the last column here, you can see barcode. So to insert here a barcode information, you simply need to scan a barcode and it will be populated in this field. And as soon as you scan another barcode and you want it to be integrated, it will be populated, being saved with all the next lines until another barcode is scanned. So again, everything went fine here, and that's great. Now let's simulate an error. So here, what happened is that I reached the target torque before the minimum angle, virtually making a cross-thread application. So the error code appears here in the line 4, error code 330. And as you could see also, it's displayed on the screen of the controller with the error code, the explanation of what is the error, and at the same time, an alarm signal is sent on the 25-pin I/O, enabling any PLC connected to it to detect this error and have actions taken upon it. Same goes if we reach a maximum angle, simulating parts being forgotten. So here in this case, we reached 1500 degrees, the tool stopped, the controller sent an error signal. This error is saved on the data, and again is sent on the 25-pin I/O. Once we stop this data collection in real time, we can save it. And as you can see, it will be saved under a CSV file that will be very easy to use for you later on under any circumstances. So this was the data collection. Now there is another type of data that's important. It's the graph function. So why is the graph important? Well, first of all, graph can help identify when something is wrong on the assembly. So you notice the production is not going as smooth as you want. There is something that looks a bit weird in the assembly process. So you use this graph function, check what's happening on the fasteners, and the graph will really help you understand the different steps of the fastening so that you can take action, adjust the settings of the tool, and make sure that the fastening happens smoother. It can also help in the programming for the angle windows to make sure that the target torque is reached between those angles. So let's have a look here with two different channels. We have channel 1 being torque, and we'll select channel 2 being speed. I start the function, make a fastening. And here what we see in blue is the torque, and in red is the speed. So we see that the fastening happens very smoothly. We then reach the sitting point of the screw. The tool slows down until we reach the target torque. And the fact that the tool slows down at the very end of the fastening will help improve productivity, making sure that the tool turns fast doing all the major part of the rundown. But it will also really help improve quality, accuracy, and repeatability for each of the fastening. So it's kind of a double win. A third part that's important here with the data collection, and this is going to talk to all your quality departments and all of you who are related to quality control, is the capability of the tool. So the tool can be operated to make its own capability directly on production. So to do that, I've created a fastening sequence, and I will show you how it looks like. So I enter the controller's parameters, and then we have the possibility to create multi-sequences. So we can use this for different aspects, such as soft joint application, helicoil, but here I will use that to make several fastening on the same screw through one trigger event. So the first line is to count until 9. We will then fasten using the preset number 3, have a 200 milliseconds delay, turn counterclockwise for 3 turns, so 1080 degrees. And as we do that, the tool will sub one value every time, buckle back until we reach 9, and then we will have a final step of again fastening using preset number 3 with a 200 milliseconds and the end, which would send a cycle complete signal on the I/O. Now you see that I'm using preset number 1 to use the multi-sequence. I select it on the screen, and now we have the different steps of the multi-sequence being presented here. I will move the driver to an unfastened screw and start the process. So the process stops after 10 fastening. Of course, you can adjust the number of fastening you want to do. And here you can see the graph, and on the bottom left, the CP, CPK for that specific tool on this specific application with this specific torque. Just like for the other data, real-time monitoring graph, this can be saved under a CSV file so that you can recreate the graph and the curve very easily on any Excel application. So I hope that today you had a bit better insight into data collection, especially related to assembly line. And if you have any questions, feel free to write them down now in the chat, and our colleague Tom will read them out loud so that we can answer them. Tom, do we have any question?
Adrian, we've got a couple of questions here. So the first one is, can the ECT be integrated with our own network?
Yes, the ECT and ECD tools are manufactured to be able to be integrated with networks. There are two languages and protocol of communication that are really commonly used in the industry. The first one being Modbus protocol, and the second one being Open Protocol. Open Protocol is virtually compatible with any kind of protocol through, if necessary, a bit of managing the information to match the format and protocol communication that you are using.
Okay, and the next question is, if our internal network goes down, can the ECT store fastening data and record data?
Well, that's where the SD card comes in handy. We've discussed about the fact that the tool is going to send all the information in real time on the network through the protocol that we just talked about. And the SD card is here for those of you who don't have a network, but it's also very useful if the network goes down. Now let's imagine that the network for some reason goes down on this specific application, this specific workstation where the tools are integrated. You can rest assured that the SD card will keep on collecting all the fastening data. So it means that you can keep on producing. You don't waste production time while the network is down. And once the network goes back live even, you remove the information from the SD card and you can store it in your systems. Any other question?
Yeah, we have another question here. So we have a customer with a question regarding real time. Are you talking about hard real time or post fastening?
Here, the information is sent every time an event is finished. So it means that when the fastening is done properly or not properly, the tool will send a signal and will send the information on the output. It's the same with every type of event on the driver, whether, as an example, you switch the tool in the clockwise or counterclockwise direction, fastening or loosening, you will have a line created. And in terms again of fastening is as soon as the fastening is done, you will be able to collect this information immediately from the tool.
Okay, I think. Yeah, and I think that's all the questions we have there, Adrian.
Okay, great. Well, thank you very much again for joining us. For some of you, it's the afternoon, so I will wish you a good evening. For some of you, it's the morning, so I would wish you to have a nice rest of the day. I hope this webinar was useful again for you, and we are looking forward to receive you for the next one. Have a nice day. Bye-bye.